The goal of this video is to show you how to solve problems involving the normal distributions. As stated before, our model is the state, plan, do, conclude model, and we will use this model for every type of problem solving that we have in the course. The way we use that model for normal distributions is as such. For state, we're going to express the problem in terms of the observed variable x. In other words, we're going to define our variable. In the planning stage, we're going to draw a picture of the distribution. We're going to shade the area of interest under the curve. Do, perform all calculations. We're going to standardize x, change it to a z-score, and we're going to use table A, or a calculator, to help us find the area required. Conclude, as always, write the conclusion in the context of the problem. Our example is one looking at Tiger Woods on the golf range. So on the driving range, Tiger Woods practices his swing with a particular club by hitting many balls. When Tiger hits his driver, the distance the ball travels follows a normal distribution with mean 304 yards and standard deviation 8 yards. Let's take a look at question 1. What percent of Tiger's drives travel at least 290 yards? The first step is to express the problem in terms of the variable x. In other words, we want to define our variable. That's as simple as saying, let x equal the distance the golf ball travels in yards. Give as much information as you can. Then we want to tell what we know about that variable x. X follows a normal model with a mean of 304 and a standard deviation of 8. Again, the n here says that x follows a normal model. 304 is the mean, mu. 8 is the standard deviation, sigma. Step 2 is the plan. We want to draw a picture of the distribution, complete with scaling the axis accurately by standard deviations, and we want to shade the area of interest under the curve. So here's how that will look. Setting up my horizontal axis, try and draw this curve as symmetrically as you can. You'll get better at it as you go. And then we'll scale it according to mean and standard deviation. The mean is 304. And the standard deviation is 8 units. This is a 304. So plus 8, there's 312. Plus another 8 is 320. Plus another 8 is 328. If I go below the mean, now I have to subtract 8. So minus 8 is 296. Minus 8 again is 288. And minus 8 again is 280. So now I want to give this a label. We'll call this golf ball distances. And we'll also give it units of yards. Then I want to shade the area of interest. We're interested in the ball traveling at least 290 yards. So 288 is here, 296 is here. I'm going to estimate that 290 is about here. And at least means that number or higher. So we're interested in everything to the right of 290. So at least 290 can be 290 or more. So this orange represents the shaded area of interest. Do, we want to actually perform the calculations. Make sure you show your formulas, and then we're going to use table A. So let's begin with standardizing x. That just means change it to a z-score. So the formula for a z-score is that z equals the observation value x minus the population mean mu divided by the population standard deviation theta, and we'll plug in the numbers we have. The observed value is to 290 yards. That's our starting point. We're subtracting our mean of 304, and we're dividing by our standard deviation of 8. And when we finish that, we find that z equals negative 1.75, which says that our value is 1.75 standard deviations below the mean. And you can see that a bit here. So this is our mean of 304. That's 1 standard deviation. And this is 2 standard deviations. And we're not quite 2 standard deviations below the mean. Now we want to make a statement about what we're looking for. We want to know the percent of Tigers drives that travel at least 290 yards. So because this is a normal distribution, the z-score is attached to a percentile under the normal curve. The only way we're going to be able to find that is to take a look at Table A. From Table A, we're going to be able to find the probability that x is greater than or equal to 290, which is the same as the probability that z, since we've standardized it, is at least negative 1.75. So let's take a look at the table and see how this works. Okay, what we have here is Table A, also known as the standard normal table. And what it shows us is z-scores along the margins of the table and probabilities, aka percentiles, percentages, area, proportions in the body of the table. So our goal is to find our z-score, which was negative 1.75, and here's how we read that. In the left column, we want to find the ones and tenths place, negative 1.7. So we would be on this row. And then we want to see where that matches up to the column where the hundredths place is 0.05. Notice that it starts at 0.00. So I'm going to go again to negative 1.7. That would be negative 1.70, negative 1.71, negative 1.72, negative 1.73, negative 1.74, and then negative 1.75. So we're interested in this number, 0.0401. Here's what you have to recognize. That 0.0401 corresponds to the area or proportion or percent or probability to the left of the z-score. So we have to use what we understand about the fact that the normal distribution is a density curve. The entire area underneath is 1. So if I know the part on the left, in order to find the area on the right, I would need to take 1 and subtract the area that is on the left. And so that's what we'll do. So we just saw that the table gives us the probability that z is less than or equal to negative 1.75. But in order to find the area to the right, the shaded orange area here, I would need to subtract that left area from 1. So again, the table gives us this part. Tells us it's 0.0401. And we need to find the orange part. So we will write this as 1 minus 0.0401, and we find that this is 0.9599. The final step is to conclude. We always want to write a conclusion in the context of the problem. Answer the question that was asked. What percent of Tigers drives travel at least 290 yards? Include the context in your response. With 0.9599 being the area to the left, that's the proportion of drives. We want the percentage, so just change it to a percent, multiply by 100, and respond to the question. So we can say about 96% of Tigers drives travel at least 290 yards. So again, to review, we have state, define the variable, describe its distribution. Plan, draw the symmetric normal curve, label according to standard deviations. Yes, that is all required. Label so that we know what the values represent. Do, calculate the z-score, including showing the formula. Use Table A in the way that we described to find the probability that you're looking for. Again, probability, area, percent, proportion are all synonymous when it comes to the normal curve. And then lastly, conclude. Answer the question that was asked, paying attention to context. That concludes this video. I would recommend that you practice some problems with this. Maybe even try numbers 2 and 3 from above. Based on examples that are in the book, you should be able to do those. Come to class ready tomorrow to practice, and I'll see you there.